Given by Jordan, going to add book, we can continue.
Yeah. Okay, hi everybody. So I'm going to be talking about some exciting work out of Duolingo by Burr and Brendan Meter. I have no connection to this work. I did not work for Duolingo. Burr had some passport issues, and so I'm going to present it to the best of my ability and try to answer your questions as well. But any errors are my own and should not be attributed to the fine folks at Duolingo. Okay, that being said, let's start. So to lay the groundwork a little bit, about 1/5 of the world is trying to learn another language other than their first language. And there are many reasons people want to do this, for love, for business, for travel, or just out of curiosity. And as NLP members of the community, we should try to encourage this. We love language, we love people learning about language, and we can do this by allowing people to learn a language on their mobile device. More people have access to a mobile device than indoor plumbing. And so we should be able to help them do this. This is the mission of Duolingo, to make language learning universal and free. And since its launch about 5 years ago, there are hundreds of millions of people using this wonderful tool to learn languages from Esperanto to Trainable. And I'm a user of Duolingo, a very satisfied one, which is one of the reasons I was very excited to be able to present this great work. Duolingo has become very popular in part because they come from the machine learning and NLP community, and part of their success is that they've embraced empirical techniques to help students get engaged with the lessons that they're learning. So what I'm going to talk about is, first I'll give a brief overview of what Duolingo does, in case you're not a user of Duolingo, and then I'll talk about one particular technique that they're using to encourage people to engage with language learning in the context of Duolingo, in particular how to model what people remember when they're learning language. Okay, so how does Duolingo work and how does it use natural language processing? So what people see when they use Duolingo is either structured lessons or a more independent directed practice. And these are ways that users access Duolingo's corpus, their data. And how do you know which kind of thing that you're looking at when you're doing a lesson or you're doing practicing? That is determined by lexeme tags. And so lexeme tags are the core organizational unit of Duolingo. So let's talk about that first, and then we'll talk about the rest of the architecture and how the lexeme tags drive how people interact with Duolingo. Okay, so lexeme tags. There are thousands of these tags for each language in Duolingo. And the way this works is you have a surface form like running. This is the word you actually see when you interact with Duolingo. There's, of course, the lemma form, and the surface form is just an inflected form of the lemma. And how is it inflected? If you've done morphological analysis, these sorts of things should be familiar to you. So for example, running is a verb in a gerund form of run. Okay, so that's the basic unit of Duolingo's content. How do those things come together in, say, a sentence? And so Duolingo is built around sentences that you practice on. So for example, Ich wollte es Euro is a German sentence that you might have encountered if you were using Duolingo to get ready to come to Berlin. And each of these words have lexeme tags. So ich is a pronoun, it's first person, it's singular, it could be male or female, it's nominative case. And similarly for all the other words in this sentence. And there's a canonical German sentence, and there are many possible German sentences. These are tagged automatically by a finite state transducer. And each canonical German sentence has several possible English translations. I require 11 euros, I need 11 euro, and whether or not a learner types it incorrectly is judged based on something like a regular expression. And so this allows Duolingo to highlight, hey, here's the thing that you messed up when you translated a sentence. Okay, so individual sentences are grouped together to help students learn concepts. These are organized into a tree, or more technically, a directed acyclic graph. And each of these individual lessons is organized thematically around a group of words, or syntactically, say, on the dative case. And once you complete one row, you can move on to the next one. Okay, so that's one way of interacting with Duolingo. The other way of interacting with Duolingo is through more directed practice. And so Duolingo tries to keep track of what each student knows. And you can think about this like a video game. This is part of the reason why Duolingo is successful. They gamify the experience of learning the language. And you have health bars that shrink over time. And this allows you to focus on the things that Duolingo thinks you need to learn. And within an individual concept, Duolingo keeps track of, here are the words within the concept that you should focus on. Okay, so how does Duolingo figure this out? We'll talk about that in a second, but first, just to emphasize that this should be personalized. Each person is individually learning the language. Not everyone learns the language in the same way. Some people have prior knowledge. This should be personalized to fit an individual user's experience. Okay, so how does Duolingo figure out these health bars for a concept? So we're going to talk about different ways of representing this. But first, a little bit of historical background. Psychology has a number of seminal results on the way that humans learn and the effect of memory on learning. And so one result is the spacing effect, which says that people learn better if practice is spaced over long intervals. So while you might cram the night before an exam, if you want to retain something over a long period of time, you should study it more than one night. Another important concept from psychology is the forgetting curve from Ebbinghaus, who was actually a professor here at Humboldt University, or the University of Berlin, until he was passed up for promotion and went elsewhere. His result shows that the probability of remembering something is a function of how long it's been since you've had to remember it, and how sticky the concept is in your memory, something that we'll call the half-life of a concept. And so concepts have some sort of intrinsic stickiness, and it's also a function of how long it's been since you've had to remember that. Another important psychological effect is the lag effect, and people generally learn better if the spacing between remembering something increases over time. And so, in other words, the half-life of the stickiness increases as you practice more and more. So, Duolingo is not the first to use these psychological insights for language learning. The Pimsleur method, which you may have heard of, is another application of this. And what's different about Pimsleur is that it's sort of a one-size-fits-all solution, which is basically what was possible if you're making language learning for the masses without the personalization possible from mobile computing devices. A sort of paper-based individualized retention method that's well known is the Leitner system. And so this is based on people learning flashcards. And the way this works is you have flashcards in boxes, and if you get a flashcard right, it goes forward in the chain, and if you get it wrong, it goes backwards in the chain, and the things closer to you are the things you'll see more frequently. So this is a way of doing this. This actually is what Duolingo used before they implemented the stuff that we'll talk about a little bit later. So one nice thing about this system is that it is personalized, and you can parameterize it in a nice way. So you can formalize the half-life as a function of the number of items that are right and wrong. And in particular, we can make it into something that looks like a linear model, which is very well known to NLP folks. And so this is what the folks at Duolingo eventually used to replace the Lightner system, and we'll get into that now. So what they wanted to do is to learn model weights from the large history of people interacting with Duolingo and either remembering or forgetting things that they're supposed to learn. So over time, Duolingo has had a lot of people interacting with the system, and they're able to calculate per session what is the probability that someone remembers, say, the word alcha. What does that mean in English? And so the probability is here on the y-axis, and the x-axis is how long it's been since you've seen that before. And each of these points can be associated with a feature vector. For example, what word you saw and how often you've gotten it right or wrong. And these are cumulative over time, as you'll notice. And what we want to do is to fit a curve that matches these points in the same parameterization that we saw before. And the objective function is that we want the recall rate to match as closely as possible. We also want the half-life, the concept stickiness, to match as closely as possible, and then we'll have, as usual, a regularization term for the feature weights. Okay, so this is a model. We can optimize this with stochastic gradient descent. Should be fairly straightforward. Okay, so we have a model. And the great thing about Duolingo is that they can deploy this at scale. So let's see what actually happens. So they first applied it to historical log data with the model I just showed you, and then some reasonable baselines, including just doing logistic regression without any sort of half-life term, just trying to match the probabilities. And also with heuristics like the Lightner and Pimsleur method. Okay, so here is the error based on the recall probabilities. And one thing that's interesting is that the models, if you take out all the features for the actual lexemes, the actual words involved, adding the lexemes doesn't help a lot. Another takeaway is that the half-life term is very important. It is the only approach that beats sort of a point estimate baseline. So the half-life regression works, and it's the only thing that works better than a really simplistic baseline. And there are lots more results in the paper. Okay, so one interesting thing you can do is you can look at the weights. So easy things are common words that are short or cognates. Hard things are rare words, irregular words, or things that come up when you're using advanced grammar in a language. So the really awesome thing is that Duolingo put this into effect. So they did a user experiment where half of the users saw the old Lightner method, and half of the users saw the half-life regression. And retention, so how many users came back the next day, increased a little bit, and but not a significant amount. And when they reached out to the users in the experimental group, the users complained that they were having to practice certain skills and words a lot. And so what was happening is that the model was overfitting on particular words that people got wrong, and this led to a bad user experience. So they did another experiment where they split the users into two groups, and half of them got the half-life regression model without lexical entries, and half did. And so here, there was a much larger increase in retention, and this was very statistically significant. And it's sort of a counterintuitive lesson. Often in NLP, we want to optimize our error rates, and in this case, not optimizing your error rates led to a better user experience and ultimately a better product. Because the goal is to help people learn, not to make good predictions. So data and code are available from Duolingo's GitHub page. And to wrap up, I talked about the great work at Duolingo using half-life regression that combines classic psycholinguistic theory with modern machine learning and NLP. And that was applied to a real-world language learning setting with millions of users. And I will try to answer any questions you might have, but if I fail to, please email Burr at Duolingo, and apparently they're also hiring, so you can email him about that too. So, thank you.
Hi, Jordan. Thanks. That was a really great talk. Question, so engagement goes up, which is fantastic, but does learning improve?
Right. So that is an excellent question. And I asked for a similar question, and they don't have clear numbers on that, but it's very clear that learning goes up the more time you spend on Duolingo. So they did that in a separate study. So it's not exactly clear, but if you believe that all else held equal, more time on Duolingo equals more learning, then it does.
Okay, cool.
Again, I know it's not your own research, so I'm curious to know why.
They use the minor and the finishing method as their baseline. Given that these both date back to the 70s, and more recently the super memo algorithms and the whole family of algorithms that do exactly this.
Yeah. So right. So super memo is another method. So in contrast with super memo, which is still heuristic based, this is fit to data. And so that's the big distinction. I think it would be interesting to try this with SuperMemo. So the data are available online. You can try to see if that gives better predictions. But I think the real contribution of this work is that it's a data-driven approach and not sort of heuristically setting the weights. And I think that's where the big contribution is.
Is it fair to use the percentage correct in a session as a proxy for the probability of forgetting, given that subsequent attempts will be primed by the first one?
Right. I don't know if this is in the paper, but they did do sort of a more proper cross-validation setup, and you get the same results. However, this approach is more what they have in practice, where you are actually seeing things evolve over time, and you want to make predictions at the next step. And so they designed the experiment so that it would actually map chronologically. We're going to test on the last 10% of the data. And so I bought that argument, at least.
Okay, so we have time for one more quick question, and in the meantime, we can connect it.
Hi, thank you for the nice talk. I have a question, but I don't know if you have the answer for it or not, but if you have any Duolingo profile, there is a graph that shows your knowledge of a specific language, it gives you like 20%, 22%. But the question that comes to my mind is, do you know based on what, how do they calculate the performance or the knowledge of acquiring a specific language? And one of the things that I noticed is the number is fluctuating. For example, I saw it on my profile. I'm learning German. It used to be, for example, 22, and then it becomes lower. Thanks.
Yeah, so I have no
I
idea.
answer because it was a long question. So.
Okay. Right, so I have no idea how they calculate your overall knowledge. That's actually relatively proprietary. That's how they're making some money now, so I don't think that's public knowledge. However, to the second point, it fluctuates over time, and part of that is because of the half-life regression, I bet, where the longer you delay practicing, it goes down over time, it's just naturally the case. That would be my guess.
Okay, thank you again.